Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Marianne Freiberger.
And I'm Rachel Thomas. So last week was a very exciting week in the mathematical calendar because it was the announcement of this year's Abel Prize. So every year the Abel Prize gets awarded. It's one of the highest honours in mathematics. And as well as the glory and the honour, the winner also gets over £550,000, which isn't bad. Marianne, do you want to tell us who won the Abel Prize this year?
Yes, so the Abel Prize this year, goes to Masaki Kashiwara for his fundamental contributions to algebraic analysis and representation theory, in particular the development of the theory of D-modules and the discovery of crystal bases.
Phew, that is a lot of hard mathematical jargon. Can you give us a tiny postage stamp version of it?
All right. Okay. So basically, algebraic analysis, as the name sort of suggests, is about using algebra to work on problems from analysis. And problems from analysis, they involve things like differential equations. So it's the mathematics of change, essentially. And at first sight, that's very different from algebra, but you can use algebraic techniques. And D-modules are a sort of example of how you might use algebra to attack problems in analysis. Representation theory, very loosely speaking, is to do with group theory, often called the maths of symmetry, which is essentially algebra. Crystal bases are kind of very useful in representation theory. Now, this was a very superficial explanation, or not really an explanation at all, but we do have an article about it on plus.maths.org, which we'll put the link to it in the show notes. Now, Rachel, you already know about Kashiwara's work, right? You wrote an interesting article about him in 2018.
Yeah, I remember that was when we were at the International Congress of Mathematicians in Rio de Janeiro in 2018. And being at the ICM, the International Congress of Mathematicians, is always an incredibly exciting time. Lots of prizes are awarded, such as the Fields Medals and the Abacus Prize and the Chern Medal that Kashiwara won. But also it's a blur. So I think back in 2018, I think we had like 2 days notice of who the prize winners were going to be before they're announced. So it was this mad rush to write accessible versions, sort of kind of a more understandable version of the maths that they'd been recognized for. So I just remember sitting in, we had this little tiny kind of hotel apartment to work in, not far from the conference. And I just remember sitting at the little table in the kitchen there. And as you said, Kashiwara, one of the things that's so amazing about his work and we see again and again is his work spans different areas of mathematics and connects them up. So I just remember I ended up with this massive glossary of what all the areas were. And because what often happens in our work is you get these sort of quite hard, jargony citations, such as the one for the Abel Prize, and you have to slowly chip away. Okay, what's a D module? Okay, it's in this area. Okay, what does that area mean? And you have to keep chipping back until you get to something you can understand, and then you can build the picture back up from there. But it was really exciting, and his work was brilliant. Really such interesting work across so many different areas. But Marianne, last week before Kashiwara's Abel Prize was announced, you spoke to Helge Holden, who's a friend of plus.maths.org. We've been lucky enough to work with him a number of times over the years. Helge is the chair of the Abel Prize Committee. What did you talk to him about?
Yeah, that's right. It was really interesting to chat to him. So he told me who this year's laureate was. And he told me a bit more about the prize more generally. So unusually, there are actually 2 aims for this prize. So it's not just rewarding very good mathematician. We chatted a little bit about Niels Henrik Abel himself, after whom the prize is named. And Helge also told me why Isaac Newton will never get it.
Well, now I'm very intrigued to hear why Isaac Newton will never get it.
Okay, well, you will find out in our interview with Helge. I started out by asking him what the prize is all about and to give me a potted history.
So the first prize was awarded in 2003 to French mathematician Jean-Pierre Serre. But of course, there is a story before that. So the political background, because this is a prize supported by the government, is that Norway had been dropping in the PISA tests for school children in mathematics, and this was becoming politically unbearable. They had to do something about it, and independent of this, there had been some initiatives by various people in Norway, including some mathematicians, to establish an Abel Prize. There had been attempts 100 years before. So this suddenly on the desk of the minister, there was this proposal about having an Abel Prize in mathematics, and they had to do something about the dropping test results for Norwegian students. And they combined the two and created the Abel Prize. So the Abel Prize has two goals. One goal is to support excellence in mathematics. That's the Abel Prize. That's what we're going to talk about. The second one is to stimulate the interest in mathematics among the young. So I think it's the only prize that has this dual purpose, both to recognize outstanding mathematics and to support the interest and stimulate the interest among the young. And then it is awarded annually to one or maybe two mathematicians, and it's been going on since 2003.
So to start focusing on the mathematicians who win it, and we can talk about the other aim of the Abel Prize afterwards. So what do these mathematicians have to exhibit? Like, what do they have to have done? Is there a way that you can phrase what kind of a mathematician would qualify?
It has to be the best of mathematics, the best results, outstanding results with a lot of impact in mathematics and other sciences. And over time, it's supposed to cover the many different areas within mathematics and areas close to mathematics. And there is nothing in the statutes that says that it has to be a lifetime award. So in principle, it could be given to a young genius. But if you look back so far, it has been given to more senior mathematicians. So it has become more of a lifetime award. It doesn't have to be, though. But it's acknowledging brilliance in mathematics.
Okay, so if we come to this year's Abel Prize, so I know obviously this is still secret. It is not announced until Wednesday. But I am all on my own here. Nobody can hear what we're saying. So would you like to tell us who is this year's recipient?
Yeah, I can tell you that this year's Abel laureate is Masaki Kashiwara from Japan. He was born in 1947, and he has spent more or less his entire career in Kyoto University in Japan. And he has been working in many different areas of mathematics, covering a wide range of problems, but this is more of the abstract mathematics that is harder to relate to everyday phenomena.
So he worked in pure mathematics. I've read the citation. So perhaps we can try to get to it slightly by thinking about the fact that, I mean, when we learn mathematics at school, or even if you learn it at university, it tends to be quite divided up into geometry and algebra, and there's calculus and things. So very, very often people who end up being amazing mathematicians are people who make connections between fields.
Right.
And in this case, I mean, there is a connection between analysis and algebra.
Yeah, and that's where he started. So this, I mean, you're pointing towards something very important, namely that he's able to combine different areas of mathematics that normally consider quite far from each other. And he has done this in something, in a way that has surprised the experts in the field and opened up new avenues, so new areas to study, and pointed out relations that were not known before he had studied them. So, I mean, he started very young, and as many mathematicians of laureate quality, they have they start early and show talent at an early age. So he started very early, and already in his master's thesis at the age of 23, he made considerable progress in what is called representation theory and D modules, which he has used as a tool throughout his career. But he laid the foundation when he was 23 in his master's thesis. So he started very young, and a small fact here is that he was, in those days, his thesis was written in Japanese, which is not accessible worldwide. So, but it was studied, it was picked up, in particular by the Japanese school, and then being disseminated to the whole world. But only 25 years later, it was actually translated into English, so everybody could read the thesis itself.
So that's a long time, really, isn't it? That's a long time.
It is indeed. And Kashiwara has been an active mathematician for more than 50 years, and he's still very active, which is, it's unusual. If you start early and never give up and continue to do excellent research, you can go on forever, and he's still very active, producing high research.
Yeah, it belies. I can't remember who said that mathematics was a young person's game, but clearly that is not always the case.
That was Hardy.
G.H. Hardy, who was famous number theorist from Cambridge. Yeah, and that's clearly not always the case. But I mean, this brings me to another question, which is, how do you even go about choosing somebody? How do you scope out the field?
You can start in many places, and Japan is, of course, not a small country, and there are many excellent mathematicians in Japan. But up to now, all the laureates have been in EU/UK and the US. So this is a new fact this year. So that's one thing, and of course he is on top of his game globally. There's no doubt about it. So how do we select the winner? I mean, and I can talk a little bit about that. So one way is that everybody can nominate anyone for the prize, and this is in big contrast to the Nobel Prize, where only selected people and the organizations can nominate. But here, anyone can nominate. So the lady in the store, the young boy delivering a newspaper, anyone can nominate. There are only two constraints. The person has to be alive, so you can't nominate Isaac Newton. The second, you can nominate yourself. Okay, so we get nominations every year, and we look at the nominations, and we have, of course, access to all previous nominations. And that's another difference to the Nobel Prize, we can nominate ourselves. We are not limited to people who have been proposed by other fellow mathematicians. So we have a lot of freedom. And then we start to contact fellow mathematicians, experts in the various fields, and ask, can you compare person A with person B, and how is this important compared to another result? And then a long list of possible names becomes shorter and shorter until there is only one name left.
How long is the list usually to start with?
I don't want to be too specific, but it's long. It's unpleasantly long in the sense that it's a lot of work to reduce it. And there is no shortage of candidates. Well, there will not be a year where we couldn't find anyone deserving the Abel Prize. That's not going to happen.
Yeah.
There are always so many good candidates.
Yeah. And how much attention do you pay to having a balance between fields? So
that's a good point. We want over time to cover most of the central areas of mathematics. This doesn't imply that we cannot in 2 years in a row choose the same field because something has happened, right? There could be good reason for that. But over time, we have to cover most of the areas of mathematics. That's the goal.
And how widely do you allow the definition of mathematics to spread?
Yeah, you are pointing at a very difficult question that has been discussed repeatedly. You have neighboring areas like physics. You have emerging areas like life sciences, biology. You have statistics. You have computational math, applied math. You have chemistry. You have all sorts of areas. And it is a difficult, at some point, one would say this is not mathematics. But where do you put the cut? That is a very difficult question. And I can say that we have discussed it, and I'm pretty sure that all previous committees have discussed the same issue. Because it is a difficult question. Where do you put the border?
And how is the timeline? So the prize is announced on Wednesday. Today is Friday. When did you decide who was going to get it?
In January. So yeah, the timeline is the deadline for nomination is September 1st. So we start September 2nd, I guess, more or less, and then we meet. We discuss what are the new names, what are the old names, what is our procedure, and then we meet regularly until say early mid-January when we make the decision.
And the person who wins it, when do they find out?
Well, in the old days, they were called in the morning of the same day. That is a risky operation because you need to know that the person is close to a phone. And 20 plus years ago, the phone was not the same phone we are talking about, right? And also we need to know that the person was not traveling somewhere, right? So this was too much. This was too much. So in contrast to the Nobel Prize, where they follow this very tight timeline, we normally inform the winner a couple of days before. So when we are talking now, the winner actually knows about it. And also the winner's institution knows about it. And an increasing number of people close to the winner will know about it. So now it's a dangerous time.
And then after the announcement, which is quite an exciting thing in itself, in May, I think, there is a ceremony where the prize is actually awarded. How is that?
Yeah,
how does that play
is, of
out?
course, the big thing in some sense for the media, because we expect, I mean, for the professionals not living in Norway, the big day is next Wednesday, right, when it's announced, because then we all know, and then we can move on. But for the community closer to the prize, May 20, which is the day this year, is the key date where the recipient will receive the prize from His Majesty the King. And it's a big ceremony in the University Aula in Oslo, and there will be an official dinner hosted by the government in the evening at Akershus Castle, and there will be lectures the day after presenting the work of the laureate by the laureate and of some colleagues of the laureate and some experts in the area. So I think all in all, it is a big event in Oslo over a couple of days, and then there's a party in the academy in the evening after the lectures. And of course, for the people attending this is a fantastic event.
And now to turn to the other aim of the Abel Prize, which is to sort of nurture interest in mathematics. What kind of things do you do in that respect?
This is an ongoing process, right? This problem is never solved. New kids, you have to do the same thing to try to stimulate the interest in the young. So the main focus has been so far on two contests. One is the traditional high school contest in math, where you qualify for the International Math Olympiad, and that happens in most countries worldwide. That they have a similar thing. So since we don't have special schools for talented pupils in math or in science, they go through the regular schools here with little emphasis on sophisticated math. So in order for them to have anything to do in the Olympiad, they have a training session, and we give them, try to prepare them for this. And I'm happy to say that many of the students who qualify for the Olympiad, they go into They study at the university later on. That's, I guess, is no surprise, but not all of them go into math, which I think that's good. Because we need smart people in other sciences, natural sciences, technology, medicine. We need them in every aspect of modern life. We need smart people. So I'm happy that some of them also go into other areas than mathematics. And then we have so that's an individual competition at the high school level. Then we have at the junior high, and a little bit below that, we have a team competition. Because at that age, I think to work in teams is a better concept than sitting by yourself and struggling with impossible math problems. So that is also quite successful. And then we have various other smaller activities nationwide to try to stimulate the interest. But this problem is never solved. We hopefully make a small difference, but it's not something we can say problem solved, let's move on.
Yes. And it's interesting what you say about these people who are become interested in mathematics at school, not necessarily going into mathematics. That is not a failing, is it? I mean, I was talking to
some of my colleagues say that, well, we will all want them in mathematics. I say the opposite. We don't want all in mathematics, because to become a professional mathematician it's a challenge. I mean, and it's not everybody who can do this, even if they are very good at solving problems. There are many other talents that are needed. But my main point is that we need smart people in every aspect of modern society. And these people are very clever in, combining difficult things, having a rational argument, understand relationships in an abstract setting. They're very good at this. Problem solvers. And we need that, right? There are so many problems that need to be solved, and they are good at some of these problems.
Yeah. I was talking to somebody recently who works in artificial intelligence, and he just come back from visiting the parliament here in order to inform politicians about AI. And one of the things he was lobbying for was better mathematics education from the beginning up, because this is what is needed in artificial
and also
intelligence.
the way things are developing in AI these days, nobody is knowing where it's heading, but they all know that basic knowledge of math, computer science, statistics is instrumental. You're not getting anywhere without that know-how. So we need that. We need big numbers of people who have this competence. Otherwise, someone else is going to do it, and that will not be to our benefit. We need to do it ourselves. In the UK, in Norway, in Europe, we need to do it.
Yes. Now, final question. I mean, what are you most looking forward to about next Wednesday?
Yeah, I guess that is done. I'm looking forward to see if there is how this is received by the community. It is very interesting to see. Now we are reaching out to a different part of the world. Never happened before. Let's see how the interest will be in Asia. I mean, this is interesting.
Yeah, and it's good. Like the wider, the bigger the diversity of the people who win it, the wider the reach.
I think it is much better, and there is no shortage of talent globally. I mean, there is an amazing number of talent all over the place. Not everybody is given the same opportunity to develop this talent, but talent is everywhere. And Abel himself is an example of this. Ramanujan is an example of this. There are other examples, but that talent can pop up where you don't expect it.
Yeah, Abel. So Niels Henrik Abel is, of course, or was the mathematician after whom the Abel Prize is named. He was a 19th century mathematician, early 19th century. And he was from Norway. So why do you say this about him? He was, after all, European.
Because when Abel was born, there was no university in Norway. I mean, there was simply nothing. He grew up in an environment where, it was not clear that he would have any education at all. He was lucky. His talent was discovered by his high school teacher. And then the university had more or less started exactly at the time when he was supposed to go to university, but they really didn't have much competence in mathematics at that university. So with a rare example of deep insight. The university professors, the parliament, and the king decided that this talent had to go abroad in order to develop his talent further. So they supported him and said, you have to go to Europe to develop your talent, because we can't teach you. We don't have the competence. And they realized that they didn't have it, which is a deep insight, right?
Yes, I didn't realize that was the case, that he was supported so much by
the king, the parliament, and the university. And this is his chance, and this is a chance for the young nation, right? They have this talent. We need to give him the opportunity. So they realized with their limited insight that this was something exceptional. So it is a fantastic story, and he was sent to Paris, which was the center, and probably in some sense still is, the center of mathematics. And he was also supposed to go to Göttingen, where Gauss was, but he didn't dare to go to Gauss. Gauss was too intimidating.
Gauss was very famous, a very good mathematician.
He was one of the all-time best, right? But he was also known to be a difficult person. And for a young, uneducated Norwegian with a lot of talent and many ideas, this could have been devastating. It's not clear how this would have worked out. So he didn't dare to go to Gauss, so he went to Berlin instead, which turned out, for other reasons, to be a very good for him. Turned out to be very good, because then suddenly he came in touch with a German engineer who wanted to publish journals. He wanted to start a journal, and suddenly he saw this brilliant mathematician who was looking for outlets for his results, and the two combined, and Abel started to publish in this journal, which exists today, and it has its reputation based on Abel's early papers, because at that point it was recognized as one of the best journals, and it still is announced.
Which one is it?
It still goes by the name of the founder, the person who contacted Abel, Krelle. Krelles journal, Journal für die reine und angewandte Mathematik in German, but it's Krelles journal for everybody.
Interesting. But Abel died young.
He died at the age of 26. I mean, that's the time when modern students have not even completed their PhD. Of course, he didn't have a PhD, but he had fantastic results.
And he died. Did he die of
Yeah,
tuberculosis?
Yes. He probably contracted in Paris, where he got more and more miserable because he had handed in his dissertation to the French Academy, whose secretary at that point was Cauchy, no less than Cauchy, and he just misplaced the paper. And Abel never saw it in his life.
This is tragic, isn't it?
I mean, I start crying every time I talk about this, because he didn't have backup, right? Backup was, he didn't have a copy, he didn't make a Xerox copy of he never saw it again.
But at least his name now lives on in the prize. It lives
on forever, and it also lives on in mathematics.
That story of Niels Henrik Abel is such a tragic story, but as Helge Holden said in the interview, Abel's name crops up a lot in maths, and perhaps most famously in something called abelian groups. So abelian groups belongs to group theory, and we also have a podcast about that. We'll put a link to that episode in the show notes.
Yeah, and we'll put links to everything else we mentioned in this podcast in the show notes. If you enjoyed this podcast, then please recommend it to a friend or review it wherever you're listening to it, because it really helps other people find it. That's it for this episode of Maths on the Move. Thanks for listening, and bye for now.
Bye.